All right, here we go. This will be relatively quick. I'm only going to draw out this kind of detail on the first one. N equals 1. We get, let's see, it's a B. They're going with BN. So B of 1 equals 2. B of 2 equals 5/2. We're just plugging in numbers here. All right. I believe the limit of this would be 3, but they didn't ask that. All right, so now we got C's. So let's just blast them out. C1 equals 2, C2 equals, and I decided to go with decimals. C3 equals 2.370, C4 equals 1, C5 equals 2.488, C6 equals 2.522, and C50 equals 2.692. This seems to be getting closer and closer to something called E. Wow, that's weird. I have to do a really big number and see if we get 2.718 another time. D1 equals -2. D2 also equals -2, which is weird. D3 equals 0, and you might be like, I don't see a pattern. Well, sometimes there's no pattern. Now I gotta check that. 1 squared, 1 minus 3, 2 squared, 4 minus 6. Yep, that's the same. Might be a whole polynomial thing where it's coming up and down, hitting the same spot. What a weird idea. D5 equals 10. D6 equals 18. D50 equals 2350. All right, moving on. Again, we're just plugging things in here. B1 equals -2. B2 equals -1. And I'm just following along. I'm adding 1 each time. 2, -1, 0. B4 equals 1. B8, add them up, you should get 5. D1 equals 10. D2 equals 11. D3 equals 12.1. D4 equals 13.31. D5 equals 19.487. That's 8. Not D5. Sorry. Just plug them in, see where it takes you. Down here, V1 equals -3. V2 equals 2. V3 equals -1. V4 equals 1. V8 equals 2. Wish it was more complex. It's not. Is what you get. Alrighty. Here D equals -2, going down by 2. A8 equals first term plus -2 times 8 minus 1, which gets you 1. A1 equals 15. A sub n equals A sub n minus 1 minus 2. n is greater than, should be lowercase, 2. There's my recursive. And a sub n equals 15 plus negative 2 times n minus 1, which works. Or if you simplify, negative 2n plus 17. Over here, d equals 0.1. d8 equals 3 plus 0.1 times 7. Recursive, d1 equals 3. dn noticing a mistake in my answer key. N minus 1 plus 0.1. N is greater than or equal to 2. I like putting them together because they are one thing. And then the explicit rule, dn equals 3 plus 0.1 times n minus 1. Also known, if we want to combine it, all right, now we get to geometric. R equals 1.5. Want the 9th term, so we go with the original term times 1.5 to the 9 minus 1, which is 25.629. First term is 1. It's funny I call these D's up here. It's fine, there's nothing wrong with it, but I don't think we want to do that with that. Live and learn. A sub n equals my common ratio times a sub the previous term, and that's when n is greater than or equal to 2. And my explicit term, n minus 1. R equals negative 1. Leave it with a's. A sub 9 equals 5 times negative 1 to the 8th. 5. Just oscillating back and forth here. A1 equals 5. A sub n equals a sub n minus 1 times negative 1. And is greater than or equal to 2. A sub n equals 5 times negative 1 to the n minus 1. 5th and 9th terms, 1, 2, 3, 4, 5, 6, 7, 8, negative 3. All right, arithmetic sequence. So we'll label these term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8, term 9. And I'll do a little negative 3 minus 5 over 9 minus 5. I get negative 2. You probably figured that out a different way. 5 minus 2, actually, I'll fill this in this way. 5 minus 2, 3 minus 2, 1 minus 2, negative 1. Yep. And the other way it would be adding 9, 11, 13. So got my first term, a sub 1 equals 13. And then our recursive, a sub n equals 13. A sub n equals a sub n minus 1 minus 2 when n is greater than or equal to 2. A sub n equals 13 minus 2 times n minus 1, or negative 2n plus 15. All right, that's recursive, that's, whoops, that's recursive, that's explicit. Now we do it again for geometric. 1, negative 1 half, 3, 4, 5, 6, first, second, and 16. Not that I need to do this, but it couldn't hurt. And actually, I'm going to do that thing I did where I went, r to the 5th, 1, 2, 3, 4, 5 equals 16 divided by negative 1/2, also known as negative 32, making r negative 2 times negative 2, 1, negative 2, 4, negative 8, 16, 1/4. A sub 1 equals 1/4. A sub 1 equals 1/4. A sub n equals negative 2 times a sub n minus 1. Recursive. And then my explicit a sub 1 equals 1/4 times negative 2 to the n minus 1. A lot of work. My hands are cramping up, but hey, I'm here for you, students. So, draw a graph of the sequence. I'm doing quick and dirty. Point, 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 point. Obviously getting closer and closer to 1. So if you ask me for convergence, this converges to 1. Over here. One plus 2 over n to the n. I'd like to say, well, that's going to go to 0, so this will go to 1, but no, it doesn't work that way. So that's why you got to always graph it. It is converging to something, but get that n in here and n to the power, things get kind of weird. So don't know what's converging to, and they're not asking me to. I'm just graphing them. I would throw these on your calculator and see what happens. Good practice for you. And up it goes. And then over here. And down it goes. Yep. All right, determine the convergence and divergence, given enough terms, find its limit. So this one, take the powers, and I'll write it out. As n goes to infinity, 2n over n, because the plus 3 vanishes, goes to 2. So I would say this converges, this sequence converges to 2. And here we go. Now the power is bigger on the bottom, so as n goes to infinity, n over n squared becomes 1 over n, becomes 1 over infinity, 0. What we call bottom heavy. Converges to 0. Now over here, got this alternating piece here. So as n goes to infinity, let's see what's going on. It's bouncing, but it doesn't matter. It's still going closer and closer to 0. We just showed that. We're going to get n over n squared, which is 1 over n, which means bottom heavy. Converges to 0. And over here, we got a 0.9 to the n. Well, that's confusing, so let's write it as 9/10 to the n. All right, cool. So as 9/10 to the n, as n goes to infinity, we are multiplying constantly by a bigger one on the bottom than a top. So this would be 81 over 100, and then it's going to get bigger and bigger and bigger on the bottom. It's going to converge to 0. Graph it if you don't see it. Long story short is that this is a geometric sequence that has a r of 9/10. The first term is 9/10. So it's going to get closer and closer to 0 as you get bigger and bigger and bigger. Again, you would graph it, see if that works. Whether or not this would be a series that converges is another story entirely. So another time. Cosine just bounces, and this is just going to do this sort of thing. So as n goes to infinity, it's going to oscillate. And I always put the smaller one first. Technically, I start at 1 and go to -1, but it's going to oscillate, so this diverges. And last but not least, all right, match them up. So if you do the calculator, I mean, it's pretty straightforward. This will get you D. Should go to 2. So you see, oh, this didn't print out right. So yeah, you might have some problems. Yeah, I don't like that. I don't like that at all. Well, let's just do some different ones. This will go to 0. Smaller and smaller. So no, this will go to 1. My bad. So this definitely goes to, it's definitely B. And this will go to 0. So that's getting lower and lower. This will definitely go to A. And this will oscillate back and forth, trying to get up to 3 and -3. So that's definitely C. So I don't know if I agree with this one. Should go to 2. I don't see why it's getting smaller and smaller and smaller. So I'll just put a question mark on that one. Be nice if we could see the whole, oops, sorry. Nice if we could see the whole thing there. Looks like it's going down and getting smaller. Maybe it comes back up. I don't think so. I think that's a mistake. I think 23, 24, and 25 are good though. All right, that's it. Have fun.